Hi and welcome back. In this video we're looking at lists, tuples and sets. The first thing to do is to create a new file, and I'm going to save it and call it lists, tuples and sets.py. That's just so Atom knows that this is a Python file and gives us syntax, highlighting and things like that. In the last video we looked at variables, and we saw that we could create variables such as strings or integers, and we could essentially store the value of whatever it is that we wanted to store inside a box called, in this case, my variable. But what we noticed, maybe we didn't notice, but what was there is a variable for every value. So here's why that can be a problem. Say you have a program that calculates the average grade of a student. So a student can have a number of grades, such as grade 1, which can be 77, grade 2, that can be 80, grade 3, that can be 90. It's obviously getting better over time. And you want to calculate the average of these things. We know that an average is the sum of the elements, 77 plus 80 plus 90, divided by the number of elements, in this case 3. So we could calculate the average by saying grade 1 plus grade 2 plus grade 3 divided by 3. Also remembering that the divide has preference over the plus, so we have to put the brackets in there. Okay, so this is fair enough. But what if there are more exams? Grade 4 equals 95, grade 5 equals 100. Then we have to go back to our code and change it. Grade 4 plus grade 5 divided by 5. And then if this keeps increasing, obviously this becomes more and more unsustainable. You end up with maybe 20 variables, and then you have to change the code every time. And also having something like this means that if you've got somebody using your program and they want more grades, they're going to need to change the code and so on, so it's not really sustainable. So ideally what we would have is a way to keep adding grades without creating more variables. And fortunately we have that. It's called a list. So we can do something like 77, 80, 90, 95, 100. And then instead of grade 1, we would obviously call this grades. And here's how we would calculate an average. Now that we've got the grades, this is a list of grades, or, well, it's really just a list of numbers, but we can imagine they are grades. And they are comma separated, and they are between square brackets. So we've got 5 grades here. We've got exactly len grades here. Len is a method, just like print is, but it calculates the number of items in a list. So len grades would give us, and I'm here kind of waiting for an answer that I know isn't coming, it would give us 5, because there are 5 elements there. So let's save that, and if we wanted to calculate the sum of grades, take a wild guess as to how you would do that. And I'll give you a hint, we want to calculate the sum of the grades. I'm sure you guessed it, it is sum of grades. And that would be that. So we would sum the grades together, divided by the length of grades, which is 5, and that would give us an average. So what does that mean? Well, we can add more grades, and then sum and len automatically calculate the correct thing. So that's a list, and there is a fairly similar thing that is using single normal brackets, and this is called a tuple. The only difference with a tuple to a list is that the tuple is something that's called immutable. So we cannot increase the size of the tuple. So this tuple, for example, has 7 elements, and we can obviously add more elements here, but there are ways for our code to increase the size of grades. We can add elements using code, grades.append 108, for example. tuple grades. There. There are ways to increase the size of the list. There are no ways of increasing the size of a tuple, because tuples are immutable. Immutable, they cannot be mutated, they cannot be changed. So once you have a tuple, you cannot increase its size. And whereas you can do grades.append, or your list variable.append, and that increases the size of the list by adding an item at the end. Finally, we've also got set grades. This is not a very useful type of data in this case, but nevertheless, you could have a set of grades. And what a set of grades is, or just a set really, is a collection of unique and unordered. So what that means is they are unique. So here we've got 2 hundreds. So this would not be okay for a set. And they're also unordered, and what that means is that there doesn't necessarily have to be an order to the set. So for example, if we print grades, we will always get 77 at the start, because that's the first element. If we print set grades, we may not get 77 at the beginning. We may get 77 at the beginning, but we may also not get 77 at the beginning. So let's go ahead into the terminal and print this out. And as you can see, we printed out a set, and we didn't get 77 in the beginning. We got 80. And also, as an aside, notice how there's only 100 there, whereas in our set we've got 200s. That's because this was there twice, so one of them just got removed. So that's what unique and unordered means. And the tuple grades, they're just immutable, so you cannot increase the size. And finally, the list is sort of the most flexible of them all. You can remove elements, you can add elements, and all that stuff. In some cases, you may want to use a tuple over a list when you don't need to be able to remove or add elements. Sometimes that can be a bit safer. And you would want to use a set when you have a collection of unique and unordered elements that you may want to do set operations with. Set operations are very important, and we're going to look at them in the very next video, alongside with a couple other things that we can do with lists and tuples. So without further ado, I'll see you in the very next video, and we're going to quickly go over what we can do with these 3 data types. I'll see you there.